Hello, mathematicians. Today we are going to talk about the number system. All right? So we have real numbers. Okay? Real numbers are all of our numbers included. So we have all values are considered real. Okay? All values are considered real. So any number is real. We use this symbol here to denote a real number. Okay, it's an R with this extra piece here. When we break our real numbers up, we can think of our irrational, decimals that never end, and have no repeating pattern. So for instance, pi. We know pi goes on forever, no pattern. If we look at the square root of 3, let's type that into our calculator. Okay. Square root, so I hit second, and this button right here, you can see the square root, and then 3. Hit enter. If it gives you the square root of 3 back, there's these little arrow buttons right here. Hit that, and it should give you a decimal. And we should see that there is no pattern here, and it goes on forever. 1.73205, and it keeps going. It ends on our screen because our calculator can't fit everything. But there's no pattern to these decimals, and it goes on forever. So that is irrational. Pi or square root of 3. Okay, something like those. They go on forever, no pattern. The other side of our tree is our rational. Rational numbers are fractions or decimals, and the decimal then has to end or it has to have a pattern. So for instance, 3/4. I can write it as a fraction. All right. 0.2. It ends. 0.666. Okay. It goes on forever with a pattern. Those are all rational. Under rational, I'm going to start breaking it down a little bit more. Okay. I'm going to get rid of the decimal pieces. And I will, in the fractions, and I'm going to have integers. Okay, and these go on forever. Integers. So once I break up this section, everything else besides my irrational things that end, I'm then going to bring it down a little bit more into my integers. So no decimals, no fractions allowed. I can have negative or positive. I'm going to break it down a little bit further to whole numbers. We're going to get rid of the negatives. Okay. I'm going to get rid of the negatives for whole numbers. Then lastly, natural, I'm going to get rid of 0. So everything is real, and I either break it up as rational or irrational. And then rational, I keep breaking it down as far as I can. Okay, so those are your number, that's your number system. Now, you're going to be asked to name a number and tell which set all of it belongs to. When we do that, we're going to find the lowest spot on the tree that it fits, and then it is everything above to real. Remember, everything is a real number. So let's look at negative 5 over 22. It is a fraction. Let's look to where fractions fit on our chart. No fraction, no fraction. Here's a fraction. So negative 5 over 2 must be rational. And then what is above rational? Real. So you find the lowest spot on the chart, and it's everything above. Square root of 56. Type that in and let's see what that looks like. Make sure to hit these arrow buttons if you need to change it to a decimal. It is a decimal. Does it repeat? No. Is there a pattern? No. And it does not end, so it must be irrational. And if it's irrational, it must be real. So irrational and real. Okay. So there was no repeating and it did not end. What is the square root of 81? It's the same as 9. So if I find the number 9 on my chart, what's the lowest spot it would fit? A natural number. So we have a natural number. And what's above it? 9 also is whole. What's above that? Integers. 9 is also an integer. What's above integer? Rational, because I can write it as a fraction, 9 over 1. And everything must be real. So find the lowest spot on the tree that it is, and then it's everything above. Try the next one on your own. Let's see how you did. What is negative 6 over 3? Negative 2. So be careful, the fraction may be able to simplify into a number instead of a fraction. So double check that. Where does number negative 2 fit on here? The lowest spot, it's not in here, no negative, no negative. It must be integers. If it is an integer, it is also rational. And if it's rational, it must also be real. Let's take a look at our next ones. Now we're going to be graphing some real numbers on the number line. Okay? So negative 3 halves. What is negative 3 halves the same as? Negative 1.5. On a number line, where is negative 1.5 located? Between negative 1 and negative 2. The next one for us to do is negative 1/2. Where is negative 1/2 located on a number line? Between 0 and negative 1. Try the next two. Graph those 2 points. Where is 1 located? To the right is 0. Can put it right on the number 1. And 3 halves is the same as positive 1.5. Where is that? Between 1 and 2. Number 6, we need to graph inequalities. Now, we need to remember that since it has a line under it, it's going to be a closed circle on 8. And 8's going to be over here, doesn't fit. It'll be a closed circle on 8 because of this equals. Now, this is y is less than, so if it's less than 8, which way do we shade? To the left. Fill this in. So if it has a line underneath, it is a closed circle. So for this one, if it does not have a line underneath, what type of circle is at negative 5? Open. This is z is greater than negative 5, so which way do we shade? To the right. So you need to pay very close attention if it's open or closed, and which way we shade. The last thing we're going to talk about today is square roots. The square root of 64. This is asking you what number times itself gives you 64. So you're multiplying two numbers, it has to be the same one. What times itself gives you 64? 8 times 8. Okay? So the square root of 64 would be 8. It could also be negative it times a negative. So negative 8 times negative 8. Because that also gives you positive 64. It only wants the negative version if it has a negative here. This one would want the positive and the negative. Okay. So for an example like this, we need to figure out the square root of 49 and the square root of 256 separately. What times itself gives you 49? 7. What times itself gives you 256? Type it in a calculator if you need to. 16. And since it has a negative in front, it wants the negative option. Try this next one on your own. Let's see how you did. I need the square root of 4, which is 2. And what next did we need? The square root of 121, and that is 11. It wanted plus or minus, so plus or minus, so it could be the positive or the negative version. So take the square root of each to get our answer. Nice job today, mathematicians.